The figures above show a small block of mass 0.2 kilogram on a track in the shape of a circular arc. The block is released from rest at a height h above the floor as shown in figure 1. The block slides along the track with negligible friction and leaves it at a height of 0.4 meters above the floor and a speed of 3 meters per second at a 30-degree angle as shown in figure 2. Here, this problem is based on the law of conservation of energy. We are given the data. According to the data, we have to find out the initial height of the block. The block is making a circular arc. Okay, it is traversing a path along the circular track. Initially, it is at a height of h, and finally, it is leaving the track at a height of 0.4 meters above the ground with a speed of 3 meters per second, making an angle of 30 degrees with the horizontal. Now, according to law of conservation of energy, EI is equal to EF. Okay, so EI is, what is the EI here? Gravitational potential energy. What is EF? EF is both kinetic energy and potential energy. So equate both and then find out the initial height. Okay, so here mgh is equal to mgh plus half mv square. And then on simplifying the equation and substituting the numbers, we get h is equal to 0.8591 meters. That means this is equal to, on rounding, we get 0.86 meters. This is the answer for this question. This is single select, therefore this is the only answer for this question. Hope this helps. Thank you. Bye-bye.